Welcome students to my YouTube channel Prakash Coaching. Today we are going to continue the light and refraction chapter. In this we are in the earlier part of the video we have discussed about the image formation by a concave mirror. So in this class we are continuing the cases. So first and second cases we have already discussed. Now we are moving on to the third and fourth and the remaining part of the cases. First, in this, as you can see, the position of the object is at the center of curvature. So when the object is at the center of a curvature of a concave mirror, the image form is also at the center of curvature, but the image is of same size, means the height of the image in both object and image is the same, and the nature of the image is real and inverted. So this is a unique case in the concave mirror. Coming on to the next case. In this, the object is placed between the center of curvature and the focus. So the image which will be formed by the concave mirror will be beyond center of curvature. Size of the image, it will be enlarged. The height of the image will be greater than the height of the object. And last, nature of the image, it is real and inverted. So hope these 2 points are clear to all of you. Fifth point, when the object is placed at the focal point. When the position of the object is at the focus, the image form will be at infinity, and the size of the image will be highly enlarged, and it will be a nature, it's real and inverted. Moving on to the last case, it is a special case because in this case the object is placed in between pole and focal point. As and when the object is placed between pole and focal point, the image form will be on the right hand side of the mirror, and the image form will be enlarged and it will be virtual and erect. This is the only case in the concave mirror where a virtual and erect image is formed. So this is a special case of the concave mirror. Uses of concave and convex mirror. Let's discuss its uses, where it is used in day-to-day life. First is concave mirror. Concave mirror is used as a reflector in torches, headlights of motor vehicles. In all the motor vehicles, whether it is two-wheeler or three-wheeler, the lights are being used as a concave mirror. The concave mirror are embedded and the light is placed at the focus. So when the lights get at focus, it reflects as a high beam, and for low beam, the focus is changed. Second, used in solar cookers and solar furnaces. Again, the sunlight needs to be concentrated and the temperature of the filament needs to be heated, so that when water flows into that filament, the water gets heated. Third, used in shaving mirrors. Shaving mirrors, as you know, needs wide and magnified view, so it is also used. Fourth, used by dentists to see the teeth of the patients. Again, teeth is a very small, and to view properly in the teeth and its roots, we need to magnify the teeth. So we use concave mirrors. Second, uses of convex mirrors. In convex mirror, it is used as a street lamps to magnify the lights, to throw off the lights. Second, used as a rear view mirror by the driver of automobiles. In two-wheeler and three-wheeler, we have side view and rear view. For the rear view, we use convex mirror as it produces virtual images and magnified images. We will discuss this image formation in the next part of the topic, but here the majorly use of the convex mirror is in the rear view mirror in the automobile industry. Let's move on to another topic, that is image formation by convex mirror. So here in convex mirror there are two cases mainly, so let's discuss them one by one. In the first case, the position of the object is at infinity and the image form is at the focus, but the different point is that the image formation is on the right hand side of the mirror, which is a virtual and erect image. As you can see, position of the image infinity, position of the image at the focus behind the mirror, size of the image is highly diminished, point size, and the nature of the image is virtual and erect. In convex mirror, the image form is always virtual and erect. Second point, when the object is between the pole and the infinity. So the image form is between the pole and the focus behind the mirror. The image is diminished size of the image, and the nature of the image is virtual and erect. Now we are moving on to the next topic, which is sign convention for reflection by spherical mirrors. So in this section, we are going to discuss how the sign conventions are used, when the case is positive, negative, how it is taken, and what are the standards for calculation of the position of the image, focal length, or object, position of the object, height of the image, height of the object, magnification, and all related terms. So in this topic, we are going to discuss these points. First one, height of the image. This is the axis, and this is here is the mirror. If above the principal axis anything is measured, it is taken as positive, and below the principal axis, if anything is being measured, it is taken as negative. So these are about the height. Now, as we move distance towards the left from the mirror, we take the distance as negative, and if we move towards the right of the mirror, we take the distance as positive. You can consider this by taking an example of the Cartesian system, which we are using in the mathematics. It is a similar type of. Hope this part is clear. If any point is not clear, do mention in the comment section. Next is the mirror formula. It is a very important formula for the calculation of the image distance, object distance, focal length. And in the spherical mirror, in the reflection part, is the main formula. So the formula states that 1 upon v plus 1 upon u equals to 1 upon f, where u is the object distance, v is image distance, f is focal length. Second, magnification. It is represented by symbol m. Magnification equals to height of the image divided by height of the object. This is equals to minus v upon u. Now let's take an example to understand the sign convention and the use of mirror formula. So I have taken an example. A convex mirror used for the rear view of automobile has a radius of curvature of 3 meters. If a bus is located at a 5 meter from this mirror, find the position, nature, and size of the image. So as you can see, the convex mirror is used, and we all know in convex mirror, it is the image formation is always virtual and erect. So here again, coming to the problem, the given terms are radius of curvature is given as 3 meter. The object distance is taken as -5, because in the concave and convex mirror we know that the objects are placed on the left hand side of the mirror. Image distance we have to find out, and we have to also find out the magnification. So first of all, we need to find out focal length. For focal length, we'll use the formula f equals to r upon 2. By applying this, we get the focal length of equal to 1.5 meters. And you can see here focal length is positive, because in convex mirror, as we all know, that the focus is taken on the right hand side of the mirror, not on the left hand side. Again, using we will use mirror formula 1 upon v plus 1 upon u equals to 1 upon f. Rearranging these terms, and putting the value, we get v image distance is plus 1.15 meters. Now this plus symbolizes that the image form is on the right hand side of the mirror, not on the left hand side. Again, second, by finding magnification, we got, putting the values, we got plus 0.023. That means the size of the image is smaller than the size of the object. So its nature is virtual, erect, and smaller in size by 0.3 meters. So hope this by this example you understood the application of the mirror formula and problem solving techniques. Thank you for watching this video. Do like, subscribe and share the video.